Hello, hello, hello. How's it going,
Good
everyone?
morning. Welcome to the CAD Class Podcast. I'm Josh,
I'm Jake.
and we are stoked as usual to have you. So, a lot of fun stuff this week, Jake.
Yeah,
We are building out a new film studio, as you may
yeah.
notice. Yeah.
You guys can barely see any of it because I have the wrong lens on here. But new set was built over the week. Lots of goodies just out of frame. You can see our books there a little bit. Some goodies just out of frame. But hopefully, when we do the next course, you guys will get to see a little bit more of all the cool bits and bobs that we make throughout all of our course, the 3D printing, yada yada, all the cool stuff.
Awesome.
We've got a good week today.
We do. And I'm just checking to make sure we've gone live on the correct place. Let's see here. 1 second. I'm just going to double check on my phone to make sure we are. Okay, we are actually live in the right place. Good.
Oh, good.
All right. So let's start with our shout outs, shall we? The projects that we love for the week. So one of the things that Jake and I talk about continuously on this podcast is how much we love seeing what you all make, how much that really inspires us to want to create more content, to kind of up our game and continue to just do what we do. So please, for all of you who are new here, share what you make. We love
Share
it.
the
It's
love.
amazing. Yeah. Hey, good morning, Aaron. Nice to have you. Curious, if you're here, tell us where in the world you're calling in from, and also tell us where in the book/course you are. We'd love to know. PC Van Vleet, what is going on?
I always really love seeing everyone's projects, but I really love seeing where everyone else is from. We got a new person coming in from Alaska this week, which is fantastic. We got a couple of people from Sweden this week as well, which is kind of rad. A bunch of people from Germany, which is always really fun. But yeah, people all over the world. So
I love
exciting.
it. I love it. I love it. Yeah. So welcome, guys. Let us know, Aaron, where you're calling in from. We'd love to know. All right, let's do some shout outs.
Let's do some shout outs.
Let's do some shout outs on my favorite channel. The I Made a Thing channel. Why don't you pop it up? So PC Van Vleet from the Netherlands. It still blows my mind. I know this is I know we're in 2023, but when people tell me they're taking our class from all over the world, and we actually have evidence, and we're here talking on YouTube, projecting to the world, it's like, what a bizarre feeling.
I know, it's so cool.
All right, you on the I Made a Thing channel?
Yep.
So that one we shouted out. That was Mr. Minnick. That's PC Van Vleet. We shouted him out last week, I hope, for that project. Just let us know. There's one right below it, though, that I think came in after that date. So look at this.
This is super, super cool. It is a weirdly big part of our community, people that love making replacement car parts. I never knew it was anywhere as big as this, but I mean, it kind of makes sense. The more niche and the more simple and customized pieces that you get in basically any machinery, cars are obviously the most popular. But it's kind of lower down as you get into real specificity. They're just simple parts that can be 3D printed, very simply modeled. And this one is printed with some high heat PLA. And it looks rad. It looks like it's going to go to an off-angled worm gear. Love to see it. Looks fantastic.
Yeah, and I wonder, do you think he probably used the gear plugin? So for those of you who don't know, later on in our program, so we design a gear early in our program, and then later on in our program, we do actually use the gear plugin. Yeah. So the point of the gear project, the gear, why am I blanking? The involute gear. Yeah, the point of that project is both the math and kind of the thinking behind it, obviously, and then to get better at CAD and at sketching. It's not to make a gear. If you're going to make gears like this, you are going to want to use the gear plugin.
And we'll show you. It's that kind of roundabout way that educators kind of work, where it's the purpose is not to make a gear, it's to learn about organizing a sketch and kind of thinking a little bit more two-dimensionally for your projects. And
Yep. Yeah. And eventually, as you get better in the workflow, and I just want to mention this too, as you get better in the workflow, you can also pull things in from McMaster Car, which is a catalog of online parts. So that also is highlighted in a later project. And you're designing fewer and fewer things, and you're now like as you progress through the program, you're starting to think about how you can bring designs together into something that's functional, into something that serves its purpose. So you are not going to be designing every screw and every gear and every motor and all that kind of stuff. You're going to borrow from the library of stuff. And by the way, I feel like we should mention AI here. Probably what you'll be able to do, and I've seen some AI plugins recently, probably what you'll be able to do in the near future is have typed information that leads you to the catalog, to the information, to the CAD model that you can just kind of find. So if you type in M20 bolt or whatever, I'm making stuff up.
It'll just bring in the most common bog standard bolt, which is for most people all they need.
Yes. Okay. So anyways, awesome.
Love it.
Next up. Again, milk tea, dude. We shout out milk tea every week. I hope he joins us. I know
because they make such awesome projects.
He or she. I say he. I don't know why I said he.
They're making awesome projects.
Yep.
But it looks like they're making some ergonomic grips for some of their games. Looks really rad. So this is something that Josh and I actually have a little bit of experience with. If you guys can see all the stellated models on it, this is actually brought in from an outside CAD source, something like Grab CAD. And then actually reduce the polygon count so Fusion can handle it a little bit more efficiently, and then actually brought into Fusion360 where you can then edit it and make parts that fit onto it perfectly. But at first thought, just seeing all these kind of stellated points, I would have thought, I would have bet that this is actually a 3D scanned piece. There's a really cool thing called photogrammetry where you can take any 3D object that you want and then take a bunch of pictures of it all the way around, and you can put it through certain software, and it will actually stitch it all together. It used to be super, super expensive, really niche, and now it's relatively inexpensive. There's an app. If you've got any smartphone, there's probably a 3D scanning app on it. I've actually seen guys that will put 3D scanning cameras on drones and then fly around their house and make 3D models of it, and then 3D print like a perfect scale replica of their house. But this is actually taken from, I believe, a product line. What's kind of funky with a lot of mass production is that obviously when they're being created, they need to have a 3D model. And then as it goes through the production line, the secret, the IP of the product, whatever it is, a mouse in this case, becomes less important. So these companies will often just kind of release it to the world so that other people can make accessories for it. That's why you can get really, really high accuracy 3D models of like smartphones, cars, gaming mice, computers, anything that you want, which is usually pretty inexpensive because it literally comes straight from the manufacturer, which is always really rad. But yeah, this looks fantastic.
It makes me think too that one of the things that we should probably include in our future CAD lessons are maybe this will be version 2 of the book, but two things. One is bringing in a scanned model. So maybe we do take a scanned model and show people how to actually manipulate that in a project or two in Fusion. That is one of the big asks is, hey, what if I want to use a scanner and bring it in here? And the other is just maybe a section on more focused around pulling in other 3D models and then making edits to those 3D models. Because I think the intro to a lot of people for CAD is they find a model they like and then they say, oh, but I wish it had some feature, some functionality that it doesn't have. How do I edit that? And I know we showed that live on another pod, but I don't know. What do you think about that, Jake?
I think it's a great idea. Most phones that actually have like a Face ID, like all iPhones, they actually have a little IDAR sensor and then an IDAR reflector where it actually blasts thousands and thousands of little points all over your face, and then that reflects back, and that gives you a 3D model of your face. That's how it can actually open up your phone. And so there's tons and tons of apps to be able to do that really, really inexpensively. I remember during the pandemic, there was a company where they made an app where they can 3D scan your face, and it'll actually build in like a perfect mask that can actually be 3D printed that then fits around your face custom.
Yeah, that's kind of fun.
Which is really rad, really rad. But there's tons and tons
prosthetics
of these apps
too. You know, one of the big applications to 3D printing is prosthetics. So I wonder if we could do a really simple prosthetic as like that's actually kind of fun. Okay, I like this.
Yeah,
we're brainstorming.
There's a new company that I just saw. MKBHD did a video where they're actually taking dogs that have got missing limbs, and they can 3D scan, the appendage that's actually left, literally just with a phone. And then they'll pull that into Blender, clean it up a little bit, pull it into a CAD software to actually make the 3D printable plastic piece that then fits over it, and then can make a new leg. And they go through multiple iterations. And their entire company, it's like this tiny room in a building, and they've just got a handful of like Ender 3s going all the time, and it's fantastic. It's
What
so
if
cool.
okay, so what if maybe I mean that leads me to think maybe another chapter that we should consider is a kind of like it's a social chapter where we're like a social good. We're trying to make a couple products that we think that we can guide people to actually making at home. Oh, look at that, I'm in the Matrix. That we could guide people to making it home so that they can make casts for dogs in the area. That's okay. I like this.
Super cool.
Yeah. All right. Was that the last of the I made a thing?
There was one more. Oh, I completely closed it down. Excuse me.
Yeah, okay. I was like, all right, fine. Close it down. See if I can.
Let's bring it up. Who's the last person?
Oh, right. Oh, yeah.
Mr.
And this
Minnick.
Mr. Minnick, which is PC Van Vleet. He's here. So we can't forget to shout him out.
Yeah.
Or at least he was here. Yeah. Pretty cool. So what does that comment say? Can't really read it on the screen.
Some feet for a balloon arch, poured concrete inside to weigh it down. Thanks to all the book and all my measurements, my CAD work, it was a breeze. It's a simple thing, but I would never been able to make it or to do it the way that I did without the book. That's fantastic. So it looks like a 3D printed little hutch with some PVC coming out of it with some concrete in it. Very simple. Again, this kind of falls into that really groovy category that Josh and I really love, where 3D printing is super fun, and when a lot of people buy their first 3D printer, they print all the goodies and all the tchotchkes and props and kind of figurines, and that's really rad. That's awesome. But very, very quickly, they get kind of bored of that after they printed everything, and then actually using it functionally to then make something that you actually use solves a problem. Way more satisfying, way more fun in my mind. But yeah, this kind of stuff I love.
And there's nothing like, I think people, when they think about CAD too, it's like they go straight to this idea that it needs to be complex, that you need to make, that you're going to make a mechatronic robot with motors and gears, and which is fine, and which is amazing, right?
Which is awesome. I'd love to see
we set you up to do that, and we want to see it as well. But yeah, so much of the designs in this world just don't need to be complex.
Yeah.
Love it. Love it. Love it. All right. So yeah, shout out to you, PC Van Vleet, Mr. Mitnick on Discord. All right. Into the challenges section. Can you pop Discord back up? Let's go back into the challenges section. So I've got a couple more highlights here. If you're new in the chat, tell us where you're calling in from and where in CAD class you are. What project you're working on. All right. That is awesome. Check that out. Scale that up.
So this is the challenge for the pizza cutter project, I believe. So in chapter 7, when we kind of go in a little bit more depth into joints and assemblies and all that good stuff, we go and talk about, well, making bigger assemblies and how you can add revolute joints, slider joints, just to kind of give your projects just a little bit more life, a little bit more movability. And one of the challenges is to say, all right, you've made a pizza cutter. Now I want you to go into your kitchen and make something else from your kitchen that's got some joints to it, got some mechanical movements to it, whatever it may be. It's a very open-ended project, but it's a really good way to kind of grab a pair of calipers and try and re-engineer something from scratch. I believe this is the first person that's done it, which is, yeah, that's awesome.
I love this script. Look at that. It's like pretty complex. It's not easy.
It's really complex, yeah. It looks like he was working on it for a little while. So I think he started off with the most difficult mechanism, the most difficult bit at the bottom.
Good.
And then he was like, hey, how do I make the scoopy bit? And so we were kind of talking about it really quick, just about getting two different spheres to cut out one each other, or maybe do some revolute cutting and some revolute joining to actually get a little bit more control with it. Yeah, but it looks like he did just a fantastic job of this.
Shout out, and who did it on Discord?
Maximusaber.
Okay. Shout out to Maximusaber.
Maximusaber.
If he's on here, hopefully he tells us what the heck we're talking about. The Mobia Strip. Go to the Mobia Strip page. I loved this coloring.
Yeah, the 3D
and so we had two things. So we had the 3D printed one, which, by the way, apparently was printed on a bamboo and turned out just so slick. And then below it,
gorgeous.
I like the render below it. Look at these renders right here. The paper clip that's like rose gold. I don't know what they ended up choosing for it with that nice back. That just looks awesome. That's awesome.
Yeah, that's slick.
All right. Next up is Lego. Go to the Lego page and check this out.
Ooh,
We had some people.
Oh, wow.
We had a lot of people make the Lego, right? So shout out to everybody who did it. But then we had somebody actually print it and show us. Scroll up right there. Check that. We did get some comments. So it sounds like a couple people have tried to print these, and the tolerances are not perfect. So just FYI, we did not design these necessarily to be 3D printed. So
No.
You will definitely have to play with tolerances. We are not pretending like these tolerances are great. And especially considering how tight some of these tolerances are for these Legos to stick together, but not stick together too hard, right? This is one of those processes where I don't know how you feel about this, Jake, but 3D printing is really not ideal.
Yeah, so it really comes down to there being way too many variables that go into it. So plastic injection molding is such a great technology because it can hold its tolerances so well. You've got two big blocks of metal pushed together, inject some molten plastic, it cools down very quickly, shells come apart, and it pushes that plastic part away. And with that, you get a degree of the plastic being so hot, and then as it cooled down, it shrinks a little bit. And because we've been doing this for like 100 years, we can calculate, it shrinks exactly 2 to 3%, and so we can kind of work backwards. So the real kind of consistency that you can get with plastic injection molding is just so high. The efficiency and the tolerance are so fantastic that it's really the goal for 3D printers to reach up to it. The downside with 3D printers is that it can get pretty tight tolerances for your printer, for your material, for your setup. But if you give the exact same file to someone on the other side of the world who may be printing with the same material on the same printer with the same settings, their environment is different. So the plastic is going to flow a little bit different. It may be slightly humid, so some of the material is going to be puffed out a little bit, or the moisture inside the filament. There's so many little tiny variables that come into it that it is borderline impossible to have a verifiable, perfect amount of accuracy and tolerance between any 3D printers in the world. It can be dialed in. So if you're working on, let's say you've decided to build out a little printer farm and you've got an idea for a product, and this thing has to fit on this pre-existing product already, and you do test after test after test and it works perfectly, that's fantastic. I believe that if you print on that same printer with that same material over and over and over again, you'll get a set of prints that are pretty damn close to each other. Yeah. But if you try and take your printers to the garage, where usually it's a lot colder, or take it on a road trip, or if you move, or the company decides to discontinue it and you have to choose a different plastic, all these little tiny changes change the really tight tolerances. It may look exactly the same, but when you're talking about multiple plastic parts fitting together with a friction fit, it's just, I don't believe it's going to work super well.
Yep. And so Aaron here, Aaron says, as I understand it, authentic Legos have truly insane tolerances. Absolutely.
Yes,
a lot of fun facts about Legos, right? They're factories. I think we talked about this. Did we talk about this a while back? They have backups of backups of backups, so that if some system fails, there's another system behind it that backs it up. Lego is, I think, if you study engineering and you don't dive deep into the history of Lego, the kind of machinery that they use, the business model behind it, to me, this is like just rich and full of all those. A lot of this stuff too deals, like when you're talking plastic tolerances, when you're talking filaments and things like that, you start to have to become a plastics engineer. You have to think like a plastics engineer to get stuff to work well. So I just love thinking about and talking about Lego. Obviously, one of my favorite childhood toys too, as I'm sure a lot of people here.
Yeah, it is. There's so many little bits and pieces in the design of this that are just so genius. One of the things that I don't think a lot of people know about is when you have plastic injection molding, you've got two parts, two halves of a shell that push together. There is always something called a casting seam where the two metal parts meet together. It'll leave this little tiny proud line all the way around the plastic part. I don't know if I have anything right on hand that kind of shows that kind of perfectly. Do I? No, these aren't injection molded. Anyway, If you look at most plastic parts, you'll see a little line that goes all the way around it. And that is just where it has to go. It's sometimes called a flashing mold as well. Very, very cleverly, because Lego wants to have really perfectly smooth sides all the way around, it actually puts this passing line on this bottom edge. So if you take a Lego and flip it upside down, you'll see this bottom face isn't actually perfectly flat. There's a little bit of a lip to it. So they're finding all these really creative places to hide all of the really necessary plastic injection geometries, but still let it work with the tolerance of the toy, which is just fantastic.
Yeah, it's amazing. It's amazing.
Yeah.
All right. I've got a note here about Geocache, and I don't remember what about. So let's go into the Geocache section. And I think there was a question in there towards, right in there. That's the one. That right there.
So this is someone saying, hey, when we have the sketch for the very top section and this bottom horizontal line right at the bottom, we actually leave that undefined. And they were just saying, why is it undefined? Usually that's when we would project something and add a constraint to make sure everything is groovy. You absolutely can do that. This was purely just an example to say that you don't need to make sure that every single sketch is fully defined. Most of the time, it's really good practice to make sure that everything is already defined and looking good. But we just want to say that sometimes, in some scenarios, it's actually completely unnecessary. It's usually a ton more work to make sure that every single sketch is actually fully defined. And in this scenario, it's just not necessary. You just make sure that a line is below a certain section, and then you move on. So you can fix it if you'd like, but it's not necessary.
Yeah, and I think that's one of those things that as you just do more and more of this, and as you practice more and more, you're going to run into the kinds of problems that you only see when it's not fully defined, and then other problems you're not going to be able to fully define a sketch, and you're going to have to make a judgment call, and that just comes with practice. So yeah,
absolutely.
But good question. I don't think there were any other big ones in there. Geocache, by the way, that's one of those amazing projects where if you print it on your 3D printer and it actually screws together, that's. So we forgot to shout this project out.
Oh, the mushroom. Yes. This was fantastic. So in the challenge for this project, it's try and make a screw container that's kind of unique that you could reasonably hide in the world and people not notice. This person made this really, really killer mushroom.
Which has the container inside. I love this one. I want to see it. I want to see them prime it and like paint it like a mushroom.
Yeah.
And actually put it out somewhere in nature with a photo. So who was that? Shout out to what was the name on that one?
Johnny 3D.
Johnny 3D. So Johnny 3D, I hope you're here. You're probably not here, but we do actually have a question as well. So look at the chess piece. We never shouted that one out either.
No.
The Geocache hide chess piece.
This whole page is the cavalcade.
Oh yeah,
really good projects.
The little pill bottle from a long time ago. Because he didn't want to just put one pill by itself, and so it just says drugs on it. I freaking love that. So PC Van Vleet, Mr. Minnick on there does have a question. The mention of the Geocache had made me remember my question. Talking isn't for me today. How would we knurl a rounded object? How would we knurl around it? Like knurling a bow, for example.
Like knurling a what?
A bow. B-A-L. I don't know what that is.
A ball? Oh, like a knurled sphere, I think is what they mean.
Knurled sphere. Okay, so how would you knurl a sphere?
Bring
up Fusion. Let's see it.
Let's try and do it.
This will be our first. Ball. So ball. You were right.
Yeah.
I was like, bow. I'm like, am I too stupid to know this one? Maybe.
All right. I'm gonna do. Let's bring up Fusion. That's a damn good question, by the way. I don't immediately know, which is probably why you're gonna see me mess up. All right, let's make a sphere really quick. Let's make this 50 millimeters.
Think hand grenade. Okay, well, it's got dark in here. Think not like soccer ball. Okay, go ahead. So sphere.
Okay. So this is really cool. So the initial thing is, my initial thought is, this is something that would likely be easier and more accurate, not in Fusion, but to take it into something like Blender and then add on a knurled texture to a sphere. And then I believe there's a way where you can take like a picture of a rough surface and then tell the software that, oh, all the dark pixels are depth, so that you can actually get a really super even cut into this. As far as a sphere, God, that's a good one. Okay, let's try it out, because I would imagine this is going to be lots of different revolved cuts in different axes. So let's go ahead and make a little inverted triangle. Oops. Let's make it horizontal and equal. Let's make the bottom point directly above our origin. And let's make it 3 mil wide. Actually, no. Let's make it 2. There we go. All right. And then I'm going to be projecting the surface of our sphere. Oops. Come on, project. There we go. Is that going to give me a circle? No, that's kind of funky. All right, let's add on a 50 mil circle then. And as you can see, I'm actually going to be making this line tangent to this curve, just so I can get it right on the very edge of it. And then I'm going to be doing a revolve cut about this profile, about the red axis. Cool. So we've got this kind of round groove in there, kind of starting a knurl, and then I'm going to be coming in with a circular pattern and then revolving this cut all the way around a different axis. So I'm going to change our object type to features and say that revolved cut is what I'm looking for. And then let's say that axis right there. This is looking a little bit closer.
This looks pretty cool, actually.
So I think 13. Yeah. If I do too many, it's just going to make the computer just... Actually, no. Okay.
That looks pretty good.
So we've got a really funky, weird metallic orange. Okay. And then I'm going to... Ooh, how do I do that? I think I want to... I want to rotate all of these cuts 90 degrees. I'm not quite sure how I would do that. I think I would just do the same thing in the opposite dimension. This is a really good kind of CAD example where I'm super stumped and I'm just making it up on the fly.
Which is great.
Like
I love this. I love this. Yeah, because this is exactly as you're designing, as the other people on in the live stream right now are designing. These are the questions you're thinking. Like, wait, how am I cutting this out of that in 3 dimensions around a sphere so that it lines the pattern up? Not easy stuff.
No, really funky. Okay, aha, we have a little bit of a knurl. All right, and then let's try and revolve that revolute cut. About, ooh, which axis would it be? Oh, this is really strange. I think that one? Yeah. Oh, things are getting really weird.
Wait, what's it look like? That's actually not too bad. There's some funny, there's that middle, yeah.
There's weird poles to it.
Yeah.
Yeah, that looks a bit grenadey. Yeah, that's how I would do it. There is a really, really cool, I saw a video on Reddit years ago, and it was these guys that are making monopolar geared spheres, where you can essentially have a spherical gear that's actually cut not too dissimilar to this, but in 3 dimensions. And then it means you can put motors on either side and you're spinning a sphere in really, really accurate ways. And then you can, or very similar to a shoulder joint, and then you can add on all of these connections and it can move really, really accurately and it can pick up weights and it can spin this way and move it. It's got all 6 degrees of motion. And it looks not too dissimilar to this, but that's really, really cool. I like that. What do you think?
I just got stuck up on your words. It looks not too dissimilar, and then it scrambled my brain, and I had to think about it. So it looks similar, right?
Yeah.
It like every time people use double negative, I'm like, wait. So what's being said here? So what was the question?
What do you think? What do you think about this?
I like the thinking behind it. I like the thinking behind it, right? It's how am I revolving it? I think we're getting closer. And so this is one of those areas where you go, I'm not quite sure the best approach to it, but let's try it and see the outcome of it, which again is I think what we're really talking about and preaching about really to the world when it comes to learning CAD is thinking in 3 dimensions and thinking about additions and subtractions and combinations in 3 dimensions is not a science. It is an art.
Yeah, yeah.
And
it's a language.
Of course, there's principles behind it, and you can follow some of those and achieve. And that's hopefully what we're teaching you here. But yeah, but it's a language. You're learning it, and there's just like with language where people are telling jokes. It's like always bits of the software and always bits of this thinking that seem kind of silly or unintuitive or aren't at all obvious. But because you're in CAD and working these ideas out, you can just see what happens. It's a way to experiment really, really quickly. So love it. I mean, I can't think of another way. I can think of a lot of ways to do it, but not ones that necessarily come out better. Good. Yeah, it makes me think about geometry quite a bit. How about the second cuts staying parallel? That's what Edwin says. Welcome, Edwin, by the way. Thanks for the comment.
The second cut being parallel. Ooh, I think I know what they mean.
For all of us watching right now, here's what I have a challenge. For those of you watching right now, open up Fusion360 when we're done. Grab a sphere, make a sphere, and see if you can make some knurls that look decent, and put it in the I made it thing. I'm curious to know, and along with that, put how you made it, what the decisions you made were.
Yeah.
Keeping things straight and parallel is tough for this, but it's giving me stuff to play with. So PC Van Vleet, we want to see what you make. We know you're making stuff all the time. Edwin, same with you. Make a sphere and show us your knurls. Show us your knurls.
Gosh, this has really stumped me. I can't think of any other way to do this. I think the route of going into Blender and making it as a texture map, but then it's 3Dified.
3Dified.
3Dified. I think that's probably the best way to do it.
Yeah, yeah. So PC Van Vleet says keeping things straight and parallel is tough for this. Yeah, because we're like trying to think. Yeah, we're trying to think in 3 dimensions. That's tough. That's what makes organic chemistry so hard, I think, is you're thinking about how molecules collide. You have to think about it in 3 dimensions. Oh,
hey.
Whoa, that's cool. Wait, so they've got kind of a...
Oh, they finally have an appearance for Nell. This is probably brand new.
Wow, that's cool.
Fusion, you finally listened to us.
Good. That's awesome.
All right.
Look at that.
So then you could absolutely go into the advanced features.
Well, you can kind of see how they did it, right? Look at the lines. The lines are following along. What path are those lines following along?
This looks like an S curve. If you can see past the reflection, this looks like an S curve all the way down. Yeah.
And then the other way. So it's like, yeah, it's an S curve. You're right. Huh.
Oh,
that's cool.
Really, really funky.
That's really cool. Challenge accepted. Okay, PC Van.
Oh my god. All right, if you guys can actually make this using the design workspace, not just an appearance.
Yeah.
Hats off to you, because that's impressive.
It's tough.
So it looks like they not only have these lines, which looks like the difficulty is just getting just one of these S curves, and then obviously circularly patterning about this kind of upright pole, and then just mirroring that to get the crisscross. So it looks like getting that initial S curve is the tricky bits.
And Aaron says, oh, sorry, go ahead. Keep going.
Oh, gosh, this is really...
I love it. But one important thing while you're thinking about it. So Aaron Rosen here says, if you do Google image search for spherical knurling, you can find a reference image. Yeah, I like that too. It's like use all the tools at your disposal. If you're trying to figure out how to do something, I think there's no shame. I think there is value in trying to think things through yourself. So in not always relying on the search. So I don't want to say 100% one way or the other way, but I agree with you. Use the tools at your disposal. How do you knurl around a spherical object? Wow,
I don't even know how you'd make this in real life.
You'd need...
there is a video on it.
You'd need some...
Cool.
How would you make this in real life?
I mean,
you need to design a tool on the lathe that goes...
Yeah, these are all Blender. This is all artificial.
I don't know. I have no idea.
Outside of literally sculpting it or 3D printing it, I don't know how you do it. This sounds like a really great challenge. Yeah, because
I like
all
it.
of these pictures, they're all 3D modeled. None of them are real life.
Yeah.
All right.
Yeah.
Okay then.
I love that. That's a
God, what a
really
great
interesting
challenge
question.
idea.
Mm.
God, it makes
Looks
my
like
sphere look like crap.
Hey, you know what though? You did this live on YouTube, so not bad. And it's about the thinking, not necessarily what.
Yeah.
Right. You're gonna find these dead ends all the time where your thinking wasn't what you had hoped. It's not so clear when you actually put it on paper. Yeah. So LOL. I like how my question is snowballing. Yeah. Good question. These are the best questions. These are the best questions.
Yeah, I do love these questions.
Yeah.
I'd like to think that I know a lot about this software, or that Josh and I both, that we do know a lot about this. But yeah, these questions that really stump us, I really do love.
Yeah.
I'm gonna give it another go really quick before we take up too much time, because I think I may have figured it out, but I don't want to say my process out loud unless I'm completely wrong.
Oh, I think I have an idea too.
Well, too bad. I'm doing it first.
Do it. Yeah. I actually think I have an idea
Okay.
in my head. Not only seeing that image.
Okay. Okay. It would have to be mirrored about its bottom section. So I'm just trying to make this kind of funky S curve, and it doesn't necessarily need to follow a nice and neat path. But how does it go? So I'm looking at this one. It's kind of coming around and then going tangent up to it. Okay. Gosh, that's weird. All right. So it's going to start at the top point there.
Yeah, this is exactly.
Does that work?
I think it does. We'll see.
No, but then it would have to be 45 degrees there. Oh God, this is a fantastic question. I don't know who asked it, but good lord.
I think it was Mr. Minnick, PC Van Vleet. I think.
Dude,
yeah, it was.
Fantastic question. Okay, I'm going to try this out with a spline. Let me just add a point up there. Here and here. Fit point spline to there. Yeah, that's all I want. Why is it not letting me? That's that. Oh, that's funky. Okay. I want to make this tangent to that curve up there, and then this tangent to the 45. And then I'm going to be messing around with this curve. Yeah, sure. And then let's fix that down. Then I'm going to be circularly patterning this curve about that central axis, but I only need 2 of them. Because we did 45 degrees, it means that this curve leads into that one really nicely. And we're doing this all on a plane that is offset a little bit from the sphere's surface so that I can project this onto there. So which tool would I do? Not a split face. Oh, goodness. Maybe. Face split that one.
Goodness me. Goodness me.
I am just figuring this out as I go along.
Oh, good grief.
Oh, golly. Okay.
Yeah. What kind of other, what other silly old-timey phrases can we use here?
Oh, gee willikers.
Oh, gee willikers. We need to bring back some old phrases. Need to bring them back.
Yeah, you start, Josh.
I think we're starting right now. I think we're starting right this second.
God, what a momentous occasion.
What's a silly old phrase that you remember? Let us know in the chat.
God, podcasts don't get any more interesting than this one, guys.
It's like, I hope everybody's riveted.
Ooh, getting some errors on here. Okay. Very funky. Oh, aha. Okay. So I want to do it actually. Can I make it go the other direction as well? Yeah, that one too. It's going to give me an error because it can't go right to the very dead center, which is fine. Oh, it's freaking out. Fusion's crashing.
There you go. So really,
I should have mirrored it. No. Oh, it's totally dead. Oh, and I don't know how to force quit this. Okay.
Oh, that's hilarious.
All right. Nah, that's fine. Okay. Let me load that back up again. Yeah, I bet it did. That's fine. Oh gosh, I was so
the
close.
question that crashes. The question that crashes it.
I know. So it would have to come up to the neural triangular profile would have to meet up at the very top. Oh goodness, gosh, that is so strange. Yeah, let's open up.
PC Van Vliet says, "I'm sorry, Jake. No, this is great. No, we really mean that. We like this."
Oh, I don't know if it saved it. Oh, damn. Anyway,
that's okay.
Yeah, big challenge to you guys if you can do it. Hats off to you.
Yeah.
But I think we should move on to another.
We'll then we'll just we'll close the company down and you can have it. So whoever can do it, you just get the whole thing. We're gonna retire.
All right, come on, Josh. Give me another question.
Okay, so we had something in the silicon mold section. Let's pop in there, and then if this sparked any more questions in the chat, feel free to let us know.
Yeah. So that's going to be in the week 3 parametric design chapter.
Yeah, so go into the Discord. Let's see what there's a couple questions. Yeah, let's not break Jake.
That's fine.
Okay, so I think there's a question in here. There's a couple questions that popped up in here. Not there. It's down a little further. I don't remember exactly what it was. Suffering
down here. When I extrude the silicon block, it creates an entirely new component separate from the silicon component I already have. Trying new body does the exact same, creates a new body outside of the silicon component. Am I doing this wrong? So what they're doing, I believe, is they're working on this project with this top component activated up here. And if you're just getting into the very early stage of the book, chapter 3, and you really haven't gone into components and assemblies, activating, deactivating what all these phrases mean, then this can be really confusing. So it looks like when they're bringing this up, for me, it's joining, but for them, it's actually saying that it's making a brand new component or a new body. What I believe is going on, and who knows, this is a great example where if you have a question, sharing a picture of your screen is so much more invaluable.
Yeah, take a screenshot, show us, yeah.
Yeah, absolutely. What I believe is going on, so in this scenario, I have the entire assembly activated up there. And as they're doing this, it must be accidentally set to new components or new body as well. And when you do this, it's actually changing a different color. If you say new body, then it's also going to stay the same kind of default gray. And it's going to be added not in any of these components that we already have, but up here. It's going to make a brand new body inside the assembly, not inside any of these components down here. So what you'd actually want to do if you needed to add more silicon for whatever reason, that's when you would select join, and you can see it's actually the same color or the same translucency as the silicon below. And you can see that our silicon component in our browser is actually highlighted. So that's great. So this is when it would join, add together to the silicon, and it wouldn't become then a new component. There's very few instances where you want to make a brand new component from an extrusion. Sometimes new body, but generally, for me, it's just going to be join or cut. Do we have any other questions from this one?
I think there might have been one or two more hiding in there somewhere, maybe even a little bit older. Can't remember for sure.
Oh, yeah, trying to make a chicken. God, yeah. I love these projects.
With silicon molding, too, I was thinking, so Jake and I are working on a project with the local children's science, I guess not children, the local museum, science museum. They don't like it when you say children, but it's a children's museum. We won't tell them. But it's not a children's museum. Actually, so we went to the, we also went to the planetarium there. Got an amazing show, but
so much fun.
But we're working on the silicon molding. Made me think of this. So when I was doing a little bit of research last week for the RC balloon cars, they're going to crash into each other and try to pop the other person's balloon. So we're building this like balloon, like Mario Kart BattleBot sort of a game where cars have to crash into each other. One has to pop the balloon of another one, and the winner, obviously prevails and not having their balloon popped, right? So I was thinking through it, I was like, is it actually worth doing a silicon mold? Should we make or have the students make their own rubber wheels and have that also be a part of the project where they don't make the mold?
Kind of cool.
They don't make the mold, but they just pour their mold like day one, come in like, all right, we have some silicon molds. We're going to pour in some polyurethane or some TPU style stuff and make our own wheels. That could be fun. I thought. I don't know if we'll do it, but so silicon mold, like I like this project for multiple reasons. One, it allows you to figure out roughly how much silicone you'd need, but then also, it's useful in the real world. So sounds fun. BattleBots, make it FPV. Oh yeah. Now we're getting crazy.
Yeah.
The hard part about designing classes, I don't know if anybody in here designs classes. It's trying to figure out how exactly to fit complexity into an environment that's kind of, I wouldn't call it unknown, but it's like, how much complexity can we put in here before we start to lose all the basics? So BattleBots is a great example, right? It's like we're building things, and we want to make a class of it. Do they make the frame? Do they make the wheels? Do we buy those?
How deep do you go down the rabbit hole?
And that is, to me, that is the art of making classes. Is where in that rabbit hole do you end, and how do you, like, what is it you're trying to achieve, and what comes out the other side? So anyways, that was an aside. So silicon molding, I love it. And I was thinking about integrating into some projects that we're doing in real life.
Yeah. I love it. All right.
What else?
Looks like we got 15 minutes left.
Got about 15 minutes. So if you're new, if you're just joining us in the chat, it's awesome to have you. Let us, please ask us a question. We are running out of things that we had on our topic list to talk about here. So if you don't ask a question, then we're just going to start mucking around. Just started a local maker lab as a volunteer. I'm thinking about that stuff right now. PC Van Vleet. So you are entering a world of pain. Makerspaces are really, really hard. So kudos to you for starting it. It's awesome. It's a necessity.
They may not know
People love it.
Our history with that.
Jake and I, we were at a makerspace in Southern California, and I was running the education department. Jake was teaching tons of classes. Together, we have taught, started, built, worked on probably 250 classes, wood, metal, welding, lasers, 3D printers, all that kind of modern manufacturing equipment. And we ran probably 500 to 1,000 kids through those programs a year, 2,000 to 3,000 adults, taught teachers all over the state. And man, was that one of the hardest businesses ever in the world to run. That is insanely challenging. So PC Van Vleet, we're just referencing this right here, just started a local maker lab as a volunteer. Those volunteer hours are going to go up quickly. So let us know if you have any questions about what it takes to start those, or, feel free to hit us in the Discord as well. But tough
business. Ton of fun, though.
You get to meet a lot of really good people. You also, at some point, get to become the enforcer, which is not as fun, right?
No.
It's, hey, you don't get to do that here. We had this good idea about what it could be. Yeah.
Please try not to burn down our facility.
Please clean up. Yeah. Could you please clean up?
That being said, you do meet the most creative, bizarre people in the world, which kind of makes up for it a little bit.
And to this day, I think it was one of, if not the top learning experiences of my life. I didn't have a manufacturing background prior to that. And I learned more in those 6 years than I think I've learned at any 6-year period in my life. So, and that includes going to school, studying pharmacy, working in chemistry and biology labs, like tough. It's a lot of information that goes into manufacturing. And I think unless you're in that world, you don't really fully appreciate it. So, okay. We've got about 10 minutes left. So let's just do us. We're working on this. Let's muck around a little bit. So I found a model on Amazon. I want to see if you can find it here. So if you type in 2-wheel laser cut robot, either into Google or Amazon, I think you can find it. You can share your screen. So what I'm trying to figure out, what Jake and I are working on right now is this car project where we're going to have these BattleBot cars with balloons. And what we're trying to figure out is, so if you go to Amazon, I think you type in 2-wheel robot. I think this will give us a good start as a discussion point here. That second one. I recently made a project on my own. I needed to extrude 60 6mm circles. Okay, we have a quick question. This is good. Is there a fast or easy way to get them all to 6? Oh, heck yeah. To get them all to 6mm diameter. I tried to use the equal constraint and some became 6.973. What?
Yeah, so please never make the same thing over and over and over and over again.
Yep.
That sounds like a nightmare. You are looking for the world of patterning. So if I make a 6mm circle and I need to make a whole grid of them, then I would use the rectangular pattern tool. And you can say, all right, I want to have, let's say 10 going this way, and then I want to have another 10 going that way. And then you can adjust the amount of distance between it. You can also adjust exactly how many that you have. And because they are patterned, you only need to ever dimension that first one. All of them are going to be exactly the same. And just like every other thing in CAD, there's always a little icon that you can always double click, and then it brings up this little dialog box, and it'll tell you exactly what you can change. If you say, oh, I want the distance to be 200mm, that's going to be then doubling the width of it. And so you can go through and you can edit lots and lots of goodies.
Yep. So the pattern tool, we also have mirror functionality, which you wouldn't use in this case, but a lot of different ways to achieve the same thing using a parameter. So yeah, you could also use a parameter, but
yeah, absolutely.
But not quite. As if you know for certain that all of these circles are going to be the same diameter, then you're better off using the pattern tool, because with a parameter, you still have to draw them. Right?
Yeah.
So you're going to have to draw a circle, and then you're going to have to copy and paste 60 more. That's just a kind of a clunky workflow.
Yeah, that sounds awful. Patterns are your friend. We have got 3 different types. Oh, excuse me, only 2 of them. Circular pattern and rectangular pattern. So yeah, those will be your best friend. All right.
Yep. Any more questions? Throw them in the chat. Otherwise, we'll pop back into. We'll just work on our stuff. So we're building a robot.
Jump back and forth.
Look, so this is the frame I was thinking about right here. So just really simple. You're so welcome, Raj3775. We're just diving in here. We're getting down to some basics here. How we want to design a car frame, looking for some inspiration on Amazon, some products that already exist. So this is kind of what I was thinking, Jake, to simplify it a little bit, to keep the project costs down, is we take some inspiration from a design like this. We laser cut the frame. I like the fact that they put that wheel on the front that doesn't actually move. So it does also simplify some of the project costs. Yeah, I think that's a good design decision. And then you have this base template where you can obviously mount the batteries, and you can mount all the rest of the components. So what do you think about something like that as a starting point? We don't necessarily have to use this, and probably the gear ratios would be a little off. But
yeah, I am not 100% sure how. Is this remote controlled?
No, it's an on-off switch, I believe. Does it say it's for Arduino? I think we would just hook it up to an on-off switch.
Smart car chassis with speed encoder. I am not seeing an encoder. Yep. I think we can. I think it's you can plug in a little Arduino into it and get some extra work out of it.
That's cool. I think it might be a little underpowered. The gear ratio might be a little bit off.
Very underpowered.
Yeah, it's like you kind of want, if we're gonna have robots that are running into each other, you don't want them to like crawl into each other. That might be kind of boring. Like, oh wow.
That'd be very boring. But
you also don't want them to smash into each other so hard that.
Right? I think a little bit of smashing is fine.
A little smashing is fine, but not so much that it breaks the whole robot. And everybody's like, oh, here's my pile of junk at home. So Aaron says, and I just answered this in the chat as well. So a new guy question: how often do you guys do these podcasts? We do this every single Wednesday, 9:30 Pacific time.
Every Wednesday.
Yep. We try to hop on, answer your questions. Make sure you have a pen and paper throughout the week, or that you ask questions specifically on Discord. We try to comb through a bunch of those Discord questions. And if we haven't already answered them in a previous week, which we often have, and even then, sometimes we'll answer them again. We try to answer those questions here live on the pod.
Yep. So any good questions, leave them in the comments. If you have any questions over the week, you can drop them in the Discord. Yeah, it looks like they all use this exact same. I'm
It's
sure
really
there's
weird.
one.
I think we could get away with a
factory.
single motor and then the drive shaft in the middle, right? Like, I'm just trying to figure out if that increases the complexity or decreases the complexity.
I mean, it can't turn then. It can only go one direction.
It doesn't need to turn. They just need to go forward. Right? They're going to be on a track. Remember we talked about they're going to be on the track with walls on either side? And then they're just going to have to go towards each other. So all they need to be able to do is go forward. So we're just going to turn the on button on. I'm guessing.
I think we can probably pull in some complexity into that. But I think this sounds like off podcast.
A great place to start. Well, you know,
I think
gotta keep it interesting.
I think like we can finish it here for the day then.
We can definitely. This is way above my level, but I'm enjoying the presentation immensely. Thanks so much, Aaron. Thank you so much, PC Van Vleet, Raj 3775, and who else? Edwin,
and
if
Aaron
you're still
Rosie.
in here. Aaron, I think we mentioned. David Dickens was on for a bit. Thanks so much, David. Seeing if there's anybody else I'm missing. Did I miss anybody? Not the printed by John. That was neat. I saw that. I saw a video. I think he commented on one of our YouTube videos. I think I saw him recently on there that he was diving into Fusion360. So congratulations, printed by John. He said, I've just started designing and it is so fun. So congratulations to you. That is super, super cool. Fusion is, and CAD
it is a
in
little
general.
fun. It is a little fun.
All right.
All right, guys.
That's where we're wrapping
I think
up.
that
was the CAD Class Podcast. Again, I'm Josh.
I'm Jake.
And we will see you next Wednesday,
week.
9:30 Pacific.
Adios, guys. See ya.